Hey, my name is Alex, and this is lesson 19 for 7th grade math. For this first part, you need to factor out polynomials. So you're just finding like the greatest common monomial factor, and then you're pulling it out from the equation basically. So for number 1 here, we have 4x squared plus 2x. So if you want to find the greatest common monomial factor, uh, and you're not too used to it, then what you could do is just write it out like this. It's 2 times x plus 2 times 1 times x. And these are just like, like 4 is just 2 times 2, like the prime numbers in the factor tree. So here we see that both have a common factor of 2x, so you could pull that out. So if we pull out the 2x, you're left with 2x from here. And you're also left with the 1 here. And you need this 1 because if you think about it, right, you could double check your answer by multiplying this together. So here to multiply this, it'll be 4x squared. Then you multiply this and it'll be plus 2x. So we need this 1 to make this 2x. If we didn't have this 1 here and it's just like 0, then it would just be 4x squared, which is not correct. So this is the answer for number 1. Number 2, we have 4x cubed plus x to the power of 8. So here we could write it out just like here. So it's 2 times x times x times x plus x times 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 x. So it's a lot of x's, but if you look, we have a common factor of x to the power of 3, or just x times x times x. So if we were to pull that out, then it would just look like x to the power of 3 times 4, because we're left with 2 times 2. And then here we're left with x to the power of 5, because there's a total of 8 x's here. You're pulling 3 out, so you have a remainder of 5 x's, which is just x to the power of 5. So this is your answer for number 2. Number 7. Here, we could write it out just like the previous problems. It's 3 times 1 times x plus 3 times 2 times x plus 3 times 3. So if we look here, the greatest common factor is 3. There's a 3 in each one of these, and that's the biggest number that we could pull out. So if we were to pull that out, then it'll be 3 times x, which is just x squared, plus 2x, and then plus 3. So that's the answer for number 7. Number 8, this is 3 times x 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 minus 3 times 3 times x. And if we look, the greatest common factor is just 3x. So if we were to pull that out, it would be 3x times x to the power of 7 minus 3. And that's your answer for number 8. Okay, so this next portion, it says multiply polynomials. So for number 1, we have x times 2x squared minus 3x plus 9. So you could just distribute this x. By that, you just multiply it individually like this. So we first multiply x with a 2x squared, which will make it 2 times x to the power of 3. Then multiply the x with the negative 3x. So it will be negative 3x squared. And if you multiply with the 9, then it just becomes plus 9x. So that is your answer. Number 2, you could distribute again, just like the previous problem. So multiply the first one. So it's negative y cubed. Multiply with negative 2y to the power of 4. So it's negative 2y to the power of 5. And then multiply it with the negative 1y. So it becomes negative y squared as your answer for number 2. Okay, so number 5, we have 3x to the power of 7 times x to the power of 4 minus 4x. So here, first we could just multiply the 3x to the power 7 with the x to the power 4. So when you multiply two terms and there's an exponent, but they have the same base, then you could just add the exponents together. So it would be 3 times x to the power of 7 plus 4, which is just 11. So here, this would just be 3x to the power of 11. And then if you multiply this with negative 4x, then it will become negative 12x to the power of 8. Number 6, multiply the negative 5y with the negative 8y, so it becomes positive 40y squared. Then multiply with negative 5, so it becomes positive 25y as your answer. Okay. This next part, apply exponent properties involving quotients. So here we have 8 to the power of 10 over 8 to the power of 5. And here a rule you need to know is if you have something that looks similar to this, and there could be coefficients as well, if there's the same base, like x and x or 8 or 3 or 4 or 5 or whatever, then you could just make it so that it's that base, but it's to the power of a minus b. So in this case, it would be 10 minus 5. So this would become 8 to the power of 10 minus 5, which is just equals 8 to the power of 5 as your answer. Number 2 is the same thing, negative 3 to the power of 9, negative 3 to the power of 3. So this becomes negative 3 to the power of 9 minus 3. It's just 6. Okay. Number 3 here, a little bit more complicated. So we have 5 to the power of 4 times 5 to the power of 8, and 5 to the power of 7. This is in parentheses, which is important because if we're going to use this rule, we know that we could simplify this top so that it becomes 5 to the power of something because it's the same base. So first, you could simplify this top. So if you remember, it's x to the power of a times x to the power of b. Then this becomes x to the power of a plus b. So this becomes 5 to the power of 4 plus 8, which is just 12. Then over 5 to the power of 7. And this is equal to 5 to the power of 12 minus 7, which is just 5. Number 4, we have 1 to the power 1 over x squared times x to the power of 6. Okay, and something that you need to know here is when you have you could have negative exponents. So if you have like x to the power of negative a, then this will become the reciprocal. If you get rid of this negative, so it becomes 1 over x to the power of a. So similarly, we have 1 over x squared. So we could just turn this into x to the power of negative 2, then times x to the power of 6. So this becomes x to the power of negative 2 plus 6, which becomes x to the power of 4, which is your answer for number 4.